Okay, so now I am moving to the final part of today's session, which is panel. I would like to welcome all the panelists. So who is new is Christian Kumis, who is Head of Business Development Europe at Huasan. And then we also heard presentations from Cosimo from Thyssen, Jan from Fornadene, and Keining from Forschungszentrum Jülich. So welcome back all. Jan, could you, yeah, great. So the topic of today's panel is HJT Solar, discussing the status and outlook for a promising high efficiency technology. Yesterday we covered TOPCon, and since it was the first day, we also had a keynote from Alex Barros at CRU Exotech, who provided an overview of the technological landscape. He mentioned that HJT has a small single-digit market share and predicted it would remain a niche technology. But, however, we also have a presentation from JA. They noted that the company is continuing their development activities in heterojunction, though at R&D scale. So this is likely also the case for a few other leading integrated manufacturers. So based on this, my understanding is that many major manufacturers are pursuing heterojunction, but primarily in the lab scale. So, but companies often tend to choose a different technologies when it comes to the large scale production, with notable exceptions of a few pioneers, many of whom are represented in today's panel. So I really welcome you all here. A question to all. So just talking about the status, what are the main reasons HJT has not yet made it to the mainstream? Maybe everyone try to bring their own perspective. And since I have a lot of questions, so I really appreciate if you can be very crisp and provide a short answer.
Okay, anyone? I will begin if that's okay.
Sure.
There was silence. There are two main reasons. The first one is economical. Most of the companies that are now doing TOPCon are in survival modus, which means they are managing to make gross margin. Maybe some net margin is not possible. And if you need to do a new production line, you need money for it. And the current environment makes it very difficult to finance those new production lines if you are not an expert in it, if everything is a bit of a question mark. That's the commercial part. The technical part is most of those companies don't have a production team that knows heterojunction. So they don't know if they could actually implement all of these new technologies that are necessary to be cost effective. And they find themselves in the position that they don't know how to do it. They would need to hire people, they would need to make mistakes, and they don't have money to make those mistakes. So I believe if we were in a world where gross margins would be now at 20%, 25%, most of those players who say that they would stay away for now would be investing in 20, 40 gigawatt lines for heterojunction just to go on and do it.
Okay. Henning?
I completely agree with Christian. I think it's also a question I answered last year. I still think that that it's just because heterojunction has a later momentum. So the TOPCon is a continuation of a large market coming from aluminum BSF to PERC. So it's a continuation of something that is already very mature. A lot of people working on it. A lot of experience there, and with heterojunction, it from the time scale, it was much later. Yeah, so I mean, we are just going through the phase where we are now having 60 gigawatt of production capacity, and these people will continue to grow and expand their know-how and spread it to more people. So I think from the time scale, it's just a little bit later. But I do not want to say sometimes from a physical point of view, I think heterojunction is a better technology, but there are just much more people working on TOPCon. So I think TOPCon is a very good product, and especially because so many people have worked on it and optimized it. And I think the challenge is coming close now, that we need to look onto the system level. I mean, there are still some advantages of heterojunction if you look from the end customer's point of view. So I think this needs to be keep in mind. Yeah, thank you.
Yes, can I?
Please.
Yes, I agree with both, because TOPCon is the evolution of starting from the aluminum back surface field to PERC and then to TOPCon. Of course, there's been higher critical mass on TOPCon in terms of market, in terms of technology, and it's difficult to start with something that is new. And but I can say that since the beginning, so we started in 2018, 2019, there have been big evolution, also reduction of costs of materials, of equipment. I think there will be, as Canning told before, there is a question of momentum. There will be, let's say, more advantage of heterojunction in the next years, because we can benefit from some materials. Of course, most of them come from China, but they are important material, like the encapsulant, the approach of zero bus bar, and so on. Also, heterojunction, for example, has more difficulties in terms of costs in the assembly. I think that as we told before, going to zero bus bar, maybe we can have a sort of a unified assembly mode between TOPCon and heterojunction, so we could have also more reduction of costs. So I think it's just a momentum matter.
Okay. Jan, sorry.
Yeah, I completely agree with the other panelists. So basically, speaking from the point of a machine and equipment manufacturer, of course, transitioning, for example, from a PERC line to a TOPCon line is much easier and much cheaper, comparing to building up a new heterojunction line. And also what I can state from my point of view is obviously the higher capex that we have involved in the heterojunction equipment. So basically, customers are looking in the first glance at the capex, and if you compare the capex for a TOPCon line compared to heterojunction, of course, the capex here is much higher.
Okay, so you know, it's not completely very surprising elements what you just said. So you know, I just also want to understand, go a little one step back. Especially, I want to talk to you, Cosimo. You know, given TRISON's thin film background, it was okay, natural to start with heterojunction in the initial phase, but when transitioning to a gigafactory, and especially with a Western supply chain and know-how, wouldn't it have been easier to go with TOPCon instead of heterojunction? You know, because you could have made a choice. And what's the main reason for selecting heterojunction as your base cell technology?
Yes, this is mostly strategic, because we don't want to be fully dependent from external, let's say, not only the supply chain, but also the technology. We want to have our technology. Maybe we will have some, let's say, more Chinese equipment, more Chinese material, but we want to, let's say, manage the process and the technology, and also our vision, because we think that we can improve the technology by ourselves, by using our process development. And of course, that we will have also to maybe do some upgrade in the tools, but we want to have a certain independency on this, because I think that this is important for our history, and also because we are in Europe. And Europe, we want to, let's say, invest and to give more, let's say, more investment, and also help to innovative technology that has also some, let's say, European origin in terms of technology, and that we can manage in the future. This is very important for us.
Okay, so you know, what has really set you apart from others who are maybe still struggling behind are already shelved their projects, especially speaking from the European perspective?
It's to me the question.
Yes, yes.
Yeah.
Two, three
From
questions.
of course, the point is in terms of today we are challenged. This is a challenge, no? Because of course our competitor has reduced costs, and we have to compete quite hard. But you know that there are some initiatives in Europe, like the one that is today in Italy, or there will be tomorrow in Europe, like the Net Zero Implementation Act. And for us, it's very important because these criteria, let's say, go towards the non-pricing criteria. This means that, of course, we don't are aiming to have the full market of European PV market, but we can stay by, let's say, following European direction, and to stay in Europe with innovative technology. So for this reason, we think that within a European context, we can have, let's say, margin to compete.
Yeah, but
the other point is also, sorry, also because for our experience that we have worked with our mother company, is very important that let's say the market can trust and in the reliability products. And for us, we think that most of the low price modules don't have this kind of aspect. For us, it's important the reliability of the module.
Okay, so that it's also another interesting aspect. Unlike in India, the European cell module manufacturing Renaissance project probably has failed so far. So it looks like you will be almost the only integrated cell module manufacturers, for a while in Europe. Similar to what was the case with Meyer Burger a year ago. So what's your strategy to succeed in a very difficult market environment we are currently in now? Then you also received some funding from Europe, and so what do you also think you need from politics or political ecosystem to be successful in operation and remain so like that?
Yes, it's what I said before. Consider, of course, we received some funding because of our innovative program, also because we want to continue, and we are strongly focusing on tandem technology. And I think in Europe we have some chance to achieve these results. We have also the big advantage compared to the other player in Europe that we have behind a big company that believes a lot in investing in PV, not only in PV, let's say, installation, but also factories. And so the strategy is very important. We need to, let's say, maintain our independence. And of course, from a political point of view, it's important that, especially at the European level, there are some, let's say, support in terms of giving, let's say, priority to high quality module with high sustainability and innovative product. That, for this reason, we can have, let's say, a sort of strategic positioning in Europe. For this reason, we think we have margin to let's say, to survive and to compete in this very, very challenging environment.
Okay. So, Jan, you already mentioned that it's also very open knowledge that heterojunction requires higher capex, and now it's also interesting that you are offering the total turnkey solution, and you also came out with this PECVD solution. So first question is your turnkey solutions available as of now, or do you have a roadmap when? Are you still looking for partnerships to get into the PECVD in real mass production or testing it? So can you just give a little bit additional information about your PECVD and turnkey? Very briefly, of course.
Yeah, of course. So the HJT turnkey solution, it's available. Of course, we have been active in this field for a very long time. And regarding the implementation of the PECVD that you mentioned, so here we are closely working together with partners. We're having a lab tool here where we, in Main, where our headquarter is based, where we do the whole process development. And we are basically ready to go to implement it into the HJT line. So as I mentioned, the turnkey solution that I presented during my talk, that's available by now.
Okay, so coming to the high capex, so what are the strategies from Singular's to reduce this part of the cost structure? You know, since you are offering even the turnkey solution, so that means you should have more control. And what's your strategy here?
Yeah, so basically, let's start with the first part. So if you consider the process flow of a TOPCon line compared to a HJT line, of course, you have less process steps involved for the HJT. However, you have very complex and also, let's say, competitive vacuum-based steps involved here, like the PECVD process, which is obviously the most critical and sensitive process in the whole chain. And here, from my perspective, I can state that vacuum processes or vacuum coating equipment is always more expensive. And our strategy here is, of course, to increase the capacity of each tool. We have several strategies how to do that. But this is basically the first step and the most important step to decrease the capex here. So as one example, for example, is the PECVD. So this is basically always the main cost driver if you consider a turnkey line for heterojunction. It makes, let's say, up to 40% of the total cost. And here we developed our inline tool some years ago because here we see several advantages compared to a batch type system in terms of throughput and also further increasing throughput in the future.
Okay. So now this is a question to Christian. You know, the high costs of heterojunction have been a key reason given by several manufacturers in most of the presentations whenever they do the technology comparisons for not opting for heterojunction. So this was also highlighted yesterday by Astro Energy, and then CRU even boldly stated that the efficiency delta for heterojunction to be in cost parity with TOPCon is 2.5% absolute. So, which I don't think is anyway possible because both the technologies are really very at high level. So, but you know, and you also presented at several of our conferences where you evaluated the LCOE level, and it's kind of it kind of makes sense. So as Keining said, you know, right now it's there, so it's comparable. So where do you see this large disconnect? So for me, 2.5% absolute, and then on one hand, and then you were saying it's there. So where is this disconnect is coming from?
Good question. We would need to peek into the minds of the analysts. And I think that is the key. From outside, the manufacturer who is doing heterojunction, it is difficult to see the actual cost and the actual advancement, because you may take one manufacturer that is doing, for instance, super multi-busbar with a legacy solution that works very well, but doesn't decrease the use of silver to a level that you have another manufacturer that is already at 6 or less microgram per watt. And then this changes completely the view. And then you look into the future and you try to implement one thing or the other. And that changes completely what is the cost for manufacturing each one of the, let's say, steps in heterojunction. I believe it's lack of information. That is the reason why this number of 2% more, and just naming that number gives me a little bit of insight of what they are looking at, because I guess that they are not looking at yield differences, because they're very regionally diverse, and they depend as well on the implementation, like tracker versus fixed tilt. But it points very much in the direction that they're looking at something like the savings in installation costs due to higher efficiency, and look at that as the only point. Maybe they look at the current price indexes where the price of high efficiency is at a certain level, and they assume that's heterojunction, where the actual difference on the market is maybe just 0.5 cent to TOPCon. And not what you see in price indexes. And this creates information salad, and those people who are not used to handle heterojunction, they just maybe don't have the contacts to ask us about things or ask Ryzen, I don't know. And this creates just a misinformation snowball. I believe this is not reflecting at all the state of the technology today. And because of that, I'm just baffled by the number, and I don't know how anybody can come to that. I know that in the past, if you look at technology of 2021, yeah, because the cost of the wafer was very high, the cost of the silver is very high, all of that just didn't work out in any good way. But today, not anymore. Those lights, let's say, are 2 years too old.
And where do you think is the current status? So
the current status is the following. If you are a purchaser of a customer and you do the LCOE with the offers you get from all of us, then you see the LCOE is lower with heterojunction offers. So if you are just driven by technology and just want to get this last little bit of LCOE improvement, you order from one of the leading heterojunction suppliers. You get the lowest LCOE with the current pricing on the market for everything, almost in every segment. Maybe if you install all the panels next to each other with no gaps and you install in the north of England, maybe not. But in, let's say, in the most common application in trackers in Spain, Italy, France. But then as a purchaser, you have to think, oh, but only 2 or 3 players are doing this that I can trust. So I will just go to my 3-4 main suppliers and get the TOPCon and be boring and just do. So my boss, if something bad happens, my boss, I can tell, oh, I just was doing what everybody's doing. It's not my fault. It's not my fault. That is the situation on the market. So the reality is TOPCon is dominating just because of the volume and who is doing TOPCon. And heterojunction will grow step by step by all those players who say, I want this little bit better LCOE, or I want this proven track record from more than 20 years, because that's kind of forgotten. We talk about things, we don't talk about that. There are many reasons, and we will keep on growing, but very slowly, because there is literally not a lot of money available in the industry to increase the production capacity at module level. And yeah, that will limit more than anything else.
Okay. Kenning and Cosimo, would you like to add anything on this?
Yeah, maybe just to, because I think it's important. We keep too much a serious eye on the price of the module. This is of course not everything, because in a whole system, in the moment it is still like that. You can make larger size cells with heterojunction as compared to TOPCon, and this gives you a module with the same power as compared to TOPCon. With you can make the same power with less cells, and these less cells will give you a lower voltage of the whole module. And that means for the limitation, due to the limitation of the inverter in voltage, you can assemble maybe 2 or 3 more of the module in a stream. And this will reduce your cabling and mounting, and this reduces overall some cost. Yeah, this is one thing. And what is also not in the pricing of the watt per euro or whatever is the bifaciality. Yeah, that is something you only see as an end consumer. And also the lower temperature coefficient and the better low irradiance behavior, and all these things contribute to the better, in comparison, a better behavior of the modules in field, and that cannot be seen just in the watt per euro price. Yeah.
Yes, I agree with Kani, because of course in our case we have started the production. We have produced for NL that is installed in solar fields, and looking at LCOE, looking at cost per kilowatt hour, in let's say in also harsh environment using bifacial. We can, comparing with the TOPCon PERC, we have always demonstrated to have best results, and also we convinced our company to invest in a gigafactory. So this is an important aspect, because I think that also for TOPCon there is a very low price, but we need to see which is also the quality, as I said before, the quality of the module, because there are many, let's say paper in literature that are let's say saying problems, but also the same can happen with heterojunction if you don't use let's say good materials and you go to lower the pricing. So it's important that we make a sort of let's say distinction, because today the lower price, of course, there is the critical mass, the lowest cost of the equipment, but also the fact that materials are not so good.
Okay, so Jan, so I just want to also involve you in the discussion. So how do you see the interest in heterojunction technology compared to TOPCon or back contact in regions outside China?
So basically, it's well distributed, let's say it like this, and it's very customer specific, because we as a machine and equipment manufacturer talking to a lot of customers. There are customers that start from a green field, building up a new factory, and in that case, there's a large interest in heterojunction, of course. But if we are looking at customers who have already existing equipment, have a proven PERC line, then of course they are more emphasizing and focusing on transitioning this line to a TOPCon line. So this is what I can say from a machine manufacturer perspective.
Okay, so then do you really see any other projects kicking off next year, aside from what we already know in heterojunction out of China?
So basically, I can comment on that in that way. We have a lot of projects in the pipeline, but obviously we have NDAs in place with our customers, so I cannot, unfortunately, go more into detail
okay.
this question.
Yeah. Okay. So I think I have listed several questions, but unfortunately we are also already 10 minutes late. So I would rather like to go to the outlook part. So actually, really, let's discuss what really needs to happen for heterojunction to reach to the next level, and actually, what is the next level? So, do you foresee any strategies or disruptive technologies emerging for heterojunction, similar to the laser-fired contacts for TOPCon, that really changed the picture of TOPCon and it on a competitive landscape? So is there anything that you would like to say?
After some investigation into what is happening with development of heterojunction back contact and TOPCon back contact, I have the feeling that these two families will move together together on a BC basis. And that is going to be, I think, the ultimate end game for single junction already. Therefore, I think disruptive technologies, I think, will come with success or not success of the perovskite, I think. So in a combination with the tandem, I think the heterojunction story is now very interesting because it seems to be still like a more suitable in combination with the perovskite as compared to other crystalline silicon bottom cells. Yeah.
Okay. And Cosimo, in your roadmap, you as part of your future development, so first you mentioned you will go to the back contact and then move to the tandem. And is there any reason that you have chosen this path? Because you think tandem is still far away, to buy some time and show some...
No. Yeah, of course. We are let's say for the back contact, it's an interesting approach, but of course you need to make some changes also in the factory, in the tools. So I think it's interesting, and maybe also that TOPCon and heterojunction, we converge to a sort of back contact, and I think that heterojunction back contact is very interesting. But of course, we have to make, let's say, to deal with with what we have. We have our factory, and we want to pursue as much as possible an heterojunction with grids, and then to enter in tandem technology. I think that heterojunction is, let's say, a direct, let's say, a good platform from tandem, differently from TOPCon. For TOPCon, you need to, let's say, do a sort of modification of the TOPCon and transformation and transform it in heterojunction to go to the tandem. So I think that heterojunction is more advantageous for this point of view. And so for our, we think that today we will pursue with the heterojunction using bifacial factor, using all what we can do with the margin. Also, what has been presented before by Canning to try to reduce the dark degradation, to improve, let's say, to make a good matching between the improvement of efficiency with the nanocrystalline and to reduce the degradation. And I expect also improvement also in the tools and the possibility of having tools at lower cost in the future. I think that heterojunction has to grow to follow its evolution, its roadmap that can be improving the efficiency to 27% or maybe even more. Then there will be the back contact or directly the tandem. We think that tandem can be, let's say, achieved not so far in the future.
Okay. So Christian, I think I also know your strategy. You don't want to go to back contact and directly you want to hit the hot spot, or rather a bullseye. So why do you think it doesn't make sense to do back contact with heterojunction? That's because tandem is so soon that you can directly jump, or you don't see the benefit of the effort.
So I think you kind of went to the answer. Thank you very much.
Okay, sorry.
That's a good point. I think that the most important way of moving forward is to keep an open mind. So for instance, until very recently, doing back contact cell was so expensive that it is, I mean the process and everything, not just materials, that it was basically only for rooftop when you can command a very, very high price for the product because it's nothing compared to the margins of the downstream segment. Yeah. From what I hear on the market, some new things are coming. So it could be that back contact could be not that much more expensive to do than front. And then the condition is the following. The strategical thinking is the following. We don't have a tandem product that works well enough right now. There is only one on the market and it passes IEC, but it is questionable what's, let's say, if it's utility scale compatible with what they expect. If it becomes possible in 1 or 2 years, back contact cell is a dead end, technologically speaking. Yeah. Because for back contact cell to be with perovskite in a tandem, you need 4 terminal cells, which are a nightmare and nobody's gonna do that. And if you have front terminal and back terminal, you have a normal cell, and then you use heterojunction as the cell, because as Cosimo said, if you change TOPCon into being compatible, then you basically have turned TOPCon into heterojunction, which means that is the fundamental breaking point. If you are a manufacturer that is going to do back contact cell, and then you don't have the knowledge in heterojunction, and you don't have the knowledge of bifacial cells in heterojunction, and in 2 years, Cosimo and we come here with modules of 28% efficiency, and you are single junction and have 25% efficiency, you are out of the market. And then you close down, and then you are bankrupt. The next day. Not even waiting. So that's a kind of a dead end possible. But if it never works out well enough, or there are things like concerns about the chemical compounds that are in the perovskite. Perovskite is not perovskite. There are many types of perovskite. And some, even most of them, they have things like chemicals that you don't like how they're called inside. So If in some big segments of the market, it's either not possible to put into the market because of bad warranty conditions, because it always degrades a little bit too much, or because it's forbidden to put these things on the roof or something like that, then there is no way outside of going in these rooftop segments to back contact cell. It's the contrary situation, right? If you cannot put tandem because it doesn't work or because it's forbidden, then you will at the very end have high efficiency for rooftop and constrained terrains, and that's back contact cell. From heterojunction as well, there's no difference to do for us. So you have these two things competing, and you don't know what's happening. Maybe our back contact cell will die, or we will talk in 3 years, we wanted to do tandem, but it never really worked out, and nobody accepted it because of A, B, and C reasons. And everybody's doing back contact for rooftop and bifacial, both heterojunction and TOPCon for utility scale normal sites. And everybody's like balanced living with it, because honestly, the difference between TOPCon and heterojunction in terms of efficiency is not very high. It's just a little bit. And in terms of yield, yeah, in hot countries it's 2-3%, but it's not going to break an industry, if you know what I mean.
Yeah.
And in difference in cost, we're going to be quite similar on the long term. So that is kind of the vision. Not really breaking points until one comes, and then the breaking point happens. But we will see.
Okay, then let's have a final closing remark. So let's look into a crystal ball a little bit. So what are your views on market positioning of heterojunction in the next 5 years among the two options? You know, HJT as a standalone technology that becomes the mainstream, whether it is, you know, both sided contact or back contacted, or heterojunction remains a niche until offtake of the tandem, at which point it becomes the most preferred bottom cell for the tandem systems. So which one do you think is going to be the most probable scenario in the next 5 years?
Maybe I'll go first.
Yeah, please. But
I think it's not so. What I think is heterojunction will become a bit bigger over time because lower LCOE, but not super fast. But I believe that every player who is doing now TOPCon will have some part of production in heterojunction, just to be insured against tandem introduction. Because you can, if tandem works in, let's say, January 2026, and you have no heterojunction production facilities, you're out. But if you have, I don't know, 20 gigawatt or something, and you have people who know how to do heterojunction, then it will take 1 or 2 years, even if it works tandem, until it's really fully implemented everywhere. And then you will have time to do it, and you will have the skills, and you will manage to slide over. So I think everybody will step by step come out of the lab and put some production lines, 5 gigawatt or a bit more, until we are in a status quo where it will be either 50-50 if heterojunction is really improving so much the cost, or we will be a bit smaller than TOPCon or a bit bigger. Nobody knows that, but it will be balanced until it's decided what happens with tandem. That's my glass ball.
Okay. Cosimo?
Yeah, I agree with Christian, because there will be, I think, a gradual increase of heterojunction. This also because speaking with several also TOPCon players, they have some, what they say, pilot line of 2 gigawatt using heterojunction. So I think they still, let's say, are looking into heterojunction, because there are, of course, we need to know which will happen after this, let's say, very low price in this year. If there will be some stabilization also in terms that people will prefer more reliable module or cheaper. So I think that there will be a sort of balance, and heterojunction will grow, and then we will see what will happen with the tandem. But there will be not let's say a fast grow heterojunction in the next year or in the next 2 years. It will be gradual.
Okay, Kenny?
Yeah, what I'm more concerned about is it was not just an issue with the overcapacity that is causing the issue here, but also some issues on the demand side. This especially you can see that for example in China they have installed a lot last year. and now facing eventually some issues with the grid stability, and then they needed to slow down the whole process. So I think it's I just came to realize because of this that the business in PV, it highly depends on the limiting factors which are outside PV itself. And how fast these issues can be solved will define whether the pie will grow or shrink. And I think if the general demand is growing, I think there will be also increase in demand for heterojunction, because it is a mature technology with certain advantages, especially for some cases it has some specific needs of heterojunction. Yes, so in all, I agree with others, but I'm not so sure about really what is going how because I'm dealing with photovoltaics. I'm not dealing with things that is outside of it. But actually, one needs to look outside of the PV community in order to get an answer for what is going to happen in the next few years.
Okay, John, do you have any remarks to add?
Well, after hearing all your answers, it's quite difficult to add something new here on this place. But also from my perspective, I would see a gradual increase over the next years, but it's very much depending, of course, on the success of tandem and perovskite technology. So this is where we see a lot of interest from our customers and activities. So we also deliver or will deliver the first tools for perovskite technology. People are scaling these processes up now. So we are also very active in this field. So this is what I can add from my perspective to this question.
Great. Okay, so thank you very much for your valuable insights. This is quite a nice panel. I really enjoyed, and the session was also great. So thanks a lot to everyone for your great contributions.
Okay,
Thank you.
thank you.
Thank you.
Bye-bye.
Bye-bye. So yeah, before I go to the end of this conference, I would like to once again I would like to thank our sponsors once again: J Solar, Longi, Huasan, Jinko, Trina Solar, Astro Energy, Tongwei, ICO, JTPV, Ryzen, Cybrid, DKM, DMAX, Hanzo First, Laplace, Solamet, Hayuvi, Rena, and Singulas. And as you all know, TaiyangNews has been publishing market surveys, reports, and various technology-related reports. And the latest one from us was new solar modules overview. Basically, it summarizes most of the new solar products, module products that were introduced at leading shows. The report can be accessed for free. And then soon we will also come up with another report on inverters, and then followed by a market survey on backsheets. And already you can see our website. There are also a couple of other reports which you can download for free. So before closing our today's conference, I would like to remind you that this is a 4-day event. And we have the next part of this event that's coming up on December 10th, which is next Tuesday. And the topic would be again TOPCon. So this is TOPCon Part 2. We have also lined up very nice program. We have Fraunhofer ISE giving the keynote, and we have 4 module makers, Trina, Tongwei, Jaitai, and DMEGC, giving their insights from the product level developments. And then we also have 2 equipment makers, Rena mainly speaking on the wet chemical benches, and Lead Micro representing the thermal and deposition equipment. Then we have Cybrid, the leading encapsulation maker, talking from the material perspective. So don't forget, and after that, we also have a very nice panel, and most probably I'll be moderating the panel again, with most of the people which I have already mentioned. And then we also have Puzon from VDMA, the ITR PV wing. And so please do not forget, and try to put a reminder. We will come back with another nice session on TopCon on next Tuesday 10th, and there will be also another session on XBC that will be on next Wednesday, that is 11th of December. So thanks a lot for your patience, and looking forward to seeing you not tomorrow, of course, next Tuesday. Bye-bye. Have a nice day or evening.